Stop cleaning data manually. Look at this CRMS, shorting caps, broken emails, and junk formatting. Usually this costs you hours of work or expensive API credits. But check this out. Perfect names and repaired emails, done 100% locally for zero cost. No data leaves your machine, and you don't need an API key. Today, we are building a private AI agent using Gemma 3.4b. I'll show you how to force structured JSON output so your automation never breaks.
All right, let's get the engine rolling. First, head over to Ollama.com. This is the heart of our local setup. It's what allows us to run powerful AI models right on our own hardware without paying for API keys. Click that big download button right at the corner. Whether you are on Windows, Mac, or Linux, Ollama has you covered. Let's go ahead and grab the installer for our operating system. I'm running on Windows. So you can see here on Windows, this version is 1.2 GB and it takes a while to download. Let me just go ahead and install. Yes, it has extracted files. Yes. Now you can see this interface. Yes, you can see here it is pointing to Gemma. You notice small icon llama in the system tray, and that's how you know the service is up and running. Some sanity check we can just look at now. Now let's make sure everything is wired up correctly. I'm going to open the terminal or command prompt if you are on Windows, and we are going to run a quick health check. I'll just type Ollama space hyphen version and say enter. Voila! You can see Ollama version is 0.15.4. If you see a version number pop up like this, congratulations, you have just turned your computer into a private AI server. We are now officially ready to pull our first model. Now we have the installation complete. So I'll just check the tray here to confirm. Yes, Llama is running. So I'm going to open the command prompt and I'm going to type this command. Ollama pull Gemma 3.4p. So now that our engine is installed, we need to download our specific cleaning model. So I'm pulling Gemma 3.4b. The 4b here stands for billion parameters. I've chosen this specific version because it is the perfect sweet spot. It is a lightweight, but lightweight enough to run lightning fast on your local CPU. That is important. But it is dense enough to handle complex data logic without breaking. So depending on the connection, this takes just a minute, and once it is on your drive, it is 100% private and free to use. So I'm going to press enter. You can see that some action is happening on the screen, pulling manifest. So on the right hand side, you can see that 3.3 GB. So it depends on the speed. Okay. We have successfully pulled Gemma 3.4b. That's great. So let's switch over to Jupyter Notebook now. To protect your time, I'm going to reuse some of the pre-prepared code blocks for this demo. So let's take care of the dependencies first. So you want to ensure you have installed the Ollama TQTM environment that you're looking at. Let's execute this. So give it some time. It is executing. Okay, ignore the warnings for now. So we're good with taking care of the library installation. So that's the first step. Now we shall load the 4 pillars. So first one is planned as for data handling. Then Ollama as our bridge to local model, and TQTM for the visual progress bar. And I'm also bringing in the JSON library because structured output is non-negotiable for production level API loops. Let's execute this cell. Okay, so everything is fine. That's good news. Next, I'm going to create a synthetic CRM list to mimic the chaos that you typically find in the real world databases. Look at row number 2. We have Do Jane shouting in all caps, and we have a .con typo in the email. Traditional regex is way too brittle for these edge cases. We need an LLM that understands context. This can be thought of as our before state. Now we are going to build some intelligence that will fix all of this. So before that, let me execute this. And you can see here, we have this capitalized and we have some typo here. So we're going to remediate this in an intelligent fashion next. Now I'm going to show you, I've written a function called clean row with LLM. This is the function that is the intelligence in this that we are building. Please notice right from the word go, I have followed production standard here. Now let's look at closely this prompt. So what it is doing, please understand this. I'll spend a few minutes to talk about this. We are not just asking it to clean data. So we're giving a specific persona, that of a professional data cleaner. And we're giving 3 distinct rules, in fact, strict rules to follow. So this gives the model a framework for its reasoning. Now, the secret ingredient is this line here. Format is equal to JSON. I just scroll up a bit. Format is equal to JSON. This is a powerful feature in Ollama that forces the model into JSON mode. Without this, the LLM might try to be polite and gets chatty. Text like, sure, here is our data, which would break our Python code. By forcing JSON, we get raw structured data that we can feed straight back into our data frame. I also want to focus on a few things here. Notice here the F string. That's important to understand here. So in this F string, there are a few things happening. So you can see here, row raw underscore name. The curly braces in row raw underscore name that you're seeing is pulling the live data from a messy table into the prompt. I also want to highlight the double braces here around the JSON example. This is used with double braces because Python's F strings need that to differentiate between a variable and actual text. And this is a syntax tip. And another important I want you to focus on in this cell is Ollama.chat. I want to emphasize that this is a local call, not a cloud call. Okay, let me execute this function now. Yes, this is executed fine. Let me now put the logic to execution. Here is the code that I've prepared. The first thing we do is call this TQDM pandas. This is the professional touch. It hooks a progress bar directly into the pandas apply method. As I execute this block of code, notice you could see the blue bar. What is happening here is turning into green and it says 100% records. When this gets executed, df.progress apply. This is our local Gemma through 3.4b processing each and every row in real time. Please notice we are not sending this to a cloud server. The CPU is doing the right thinking here. Once this is finished, you already see the output. I'll talk in a bit. We convert the JSON responses back into a clean data frame, and we are displaying the data frame. So take a look at the tabulated output here. Just like this table, the names are standardized in this table. The emails are fixed. You can see .com, 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 .net. And the last column city is also properly formatted. What we have done so far, we just automated a manual task for zero cost. One more time, we are not sending this to a cloud server. CPU rather, is doing the right thinking here. You should be crystal clear about that. To wrap this up, let me get the data out of the notebook into Excel, as you can see here. So what we have done is we are exporting this to a standard Excel file using toExcel function. Let me just execute this. Yes, the file is ready. Let's just go and I'll refresh this and see if we can see the file here. Yes, here it is. I could also show in my working directory or the local directory here. I'm going to open this to show you what it has exported. So you can see here neatly we're able to export this. Let me just reduce this a bit. So you can see here all these things are sitting really well. Okay. So if you want this exact notebook that we have used here, please comment need notebook in the comment section down below. Here is the interesting part. In the next video, I'm going to take the clean data and build a local agent to find the duplicate leads. If you don't want to miss, please subscribe. Stay tuned for more. Happy learning.